Hello everyone. Today is December 30 and it's time to open a new problem from LeetCode for our Coding Advent Calendar. Today's solution is about using technique called DFS, Depth First Search. It is a technique to traverse a graph. If you are interested, let's take a look. Here is the problem for today. All paths from source to target. Giving a directed acyclic graph of n nodes labeled from 0 to n-1, find all possible paths from node 0 to node n-1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. There is a directed edge from node I to node ij. Here is an example. 0, 1, 3, 0, 2, 3. And here is how result should look like. Because there are two possible paths, 0, 1, 3 and 0, 2, 3. In this example, it's more complicated, but the target is 4. Okay. Since we are going to collect paths, we are going to use a technique called Depth First Search, or DFS. This allows us to find solution in depths of a graph, and we are going to remember it, then find another one and another one. So we are going to find we are going to have a function called DFS, and it will be returning bool, which tells that this particular function call is successful, so we found a solution. Okay, our result is a list of lists, so let's define it as this one, as this result new list of list of integers, and eventually we will return it. And we are going to pass this as an argument to our DFS, so this DFS eventually will collect all results, so it will fill this list, and then we will return it back. We also need to have something to store current path from the source to destination, and we can do this by using accumulator. And we also need to have current vortex. Okay, I guess that's enough. And from the very beginning, we will trigger this DFS. We will pass our graph there. We will pass our result there. We will pass new accumulator, which is prefilled with 0, because we start from 0, and we send 0 as current vortex. That's it. Here our DFS is a function which we will call recursively. So in the end, if vortex equal to graph length -1, so it's the last one, the last vortex, we will return true. If it's not, we're going to take current vortex and try to reach all next vertices which are available from current position. What are we going to do? First, we by taking this neighbor from current position, we need to add it to accumulator to reflect path change. Then we need to trigger DFS recursively and check if this is the end, actually, if this was the last recursive call. And if it's so, then we need to add current accumulator to our result. And we actually need to create new instance of list because we are going to modify our accumulator. So we are going to create a copy. That's it. Then we need to do the following. Since we are leaving current neighbor and try to pick another one, we need to modify our accumulator back. So we are going to remove its last value. Okay, if we went through all neighbors, we need eventually to return false. That's it. Only in case when current vortex is the last vortex is the same as the last vortex in the graph, we need to return true. That's it. Let's try to run it. Okay, both cases are accepted. Solution accepted. The time complexity for this solution is 2 to the power of n multiplied by n, and the space consumption is big O of n. I hope you enjoyed today's video. Tomorrow will be our last video for December for our Coding Advent Calendar. Don't miss it. See you tomorrow.